Hello and welcome back to another AP3 video, and in today's video we'll be going over SAT math questions, more specifically two variable data model and scatterplots. We'll be doing easy, medium, and hard questions. So without further ado, let's get started. The line graph shows the number of graduates from the class of 2001 through 2007 at a certain school who enrolled in college within 24 months of graduation. Of the following, which class has the fewest graduates who enrolled in the college with 24 months of graduation? So we're given a graph, right? We're given the years of the class of 2001 to 2007 in the x-axis, so in the bottom. And we're given with the y values of the number of graduates who enrolled in the college. So x and y on top of here. And what we're looking for is which one has the fewest graduates within the 24 people graduating, or like the 24 months of people graduation. So what we all want to do in these type of questions is just read the information and understand what we're looking for. But if we're looking for which class has the fewest graduates that were enrolling in a college with 24 months of graduation, we just want to look at which y-axis is going to have the lowest number. Let's look at every single answer, right? If we look at 2001, it has roughly 225. But if we see 2002 compared to the other classes years, it's the lowest portion, right? And it's right over here. And it's roughly about lower than 225. And because when we go to 2003 to 2007, because it's greater than 2002, and then 2001 being greater than 2002, obviously, 2002 is going to be my class that has the fewest graduates. Therefore, my answer is indeed A. Let's do another question. Teresa ran on a treadmill for 30 minutes, and her time and speed are shown on the graph above. According to the graph, which of the following statements is not true concerning Teresa's run? So if we analyze the question, we're looking for a statement that is not true. Therefore, we want to look for one that is not true with the information given. So we're going to have 3 that are right and 1 that's going to be wrong. And it's important to read the question correctly, because if you don't read it, you probably think, oh, which one is correct? In this case, we're looking for one that's the opposite. These are important keywords, so pay attention. Anytime you see capitalized, that means it's very important, because a lot of people probably get thrown off when they don't read it correctly. Okay, so let's go through all of our answer choices and see if all the answers make sense. If we look at A, Teresa ran at a constant rate for 5 minutes. Let's see if that's true. If we look at time in minutes from 5 to 10, I can see that I have a speed of 7 for indeed 5 minutes. So from 5 to 10, my speed isn't constant. And if I do 10 minus 5, that's going to give me 5 minutes. So there was a point in time where she was indeed running for 5 minutes for a constant speed. Therefore, A is a true term, so A is indeed incorrect. Let's look at C. Teresa's speed decreased at a constant rate during the last 5 minutes. If we look at 5 to 30, which are the last 5 minutes, she's decreasing the speed that she's going and at a constant rate. Therefore, C makes sense, and it's also incorrect as well. Let's look at D. Teresa's speed reached its maximum during the last 10 minutes. Well, let's see it. If we look from 20 to 30, I see I have a point at 8 when it reaches 25. And that's indeed during the last 10 minutes. And as we can see, 8 is the highest speed that she goes to. Therefore, the maximum point is between during the last 10 minutes. So D is correct. It's true, but D is incorrect. Therefore, my answer is going to be B. But let's see that. Teresa's speed was increasing for a longer period of time than it was decreasing. That basically means that she ran longer when she was increasing than decreasing. Well, let's compare. I'm doing in green. I see where she's increasing. She's increasing from 0 to 5. She's constant from 5 to 10. I'm going to do red for every time she's decreasing. She's decreasing from 5 to 20. She's increasing from 5 to 25. And then she's decreasing from 25 to 30. Let's add all the minutes that she's increasing and add all the minutes that she's decreasing. So she's increasing for about 10 minutes. And she's decreasing about more than 10 minutes. It'll be 15 minutes. And as we can see, there's more times where she's decreasing than increasing. Therefore, B is incorrect. Let's do another question. The densities of different concentrations of grape juice are shown in the scatter plot above. According to the trend shown by the data, which of the following is closest to the predicted density in kilograms per cubic meter for grape juice when the concentration of 60%? Okay, so if we look at the graph, we see that it's a straight line. And we're looking for the closest predicted density of the grape juice when it's roughly 60%. So what does that necessarily mean? So if we look at our y-axis represents density, and our x-axis represents concentration. And because the grape juice has the concentration of 60%, we want to look at the x-axis, right? So as we can see, it's going to be right here. And we're looking for the density, which is y. So if we look at the graph, I have like a linear line if we analyze it. We kind of have a straight line going from roughly 1,075 all the way up to 1,350 at 70. So because it's a straight line, I can kind of estimate what is my density when we have the concentration of 60%. And if we look at it, it kind of lands on 1,300 because that's what helps us make the straight line. So the answer is C. It can be the other choices because if the concentration of 60% is 1250, let's draw right here, that is going to break the straight line. If we do it at 1200, it's also going to break the straight line. And if we do 1350, that's also breaking the straight line, right? Therefore, my answer is ultimately going to be C. Okay, this is another easy question if you understand what we're looking for. According to the line graph above, between which two consistent years was there a greatest change in the number of 3D number release? So we're given a graph, and with the graph, we want to interpret what exactly? Between which 2 years has the greatest change in the number of 3D movies released. So the greatest change is just which one has like the greatest number increase. Well, let's see and compare. If I look at the graph, I would want to look at 2010 to 2011. That's definitely going to be one of my choices because if I look at it, the gap between both is pretty huge. I'm also be looking at 2008 and then 2008 to 2009 and then 2009 to 2010. And I picked those because those are the ones that what I see, those have the greatest change just by observing it. But now let's look at the numbers and compare which one is going to have it. If we look at 2008, we roughly have an amount of 9. And if we look at 2009, we're going to have roughly number 20. So if I do 20 minus 9, that's going to equal 11. So we're going to have an increase of 11 number of 3D movies from 2008 to 2009. It's an estimation. If we look at 2010, or like from 2009 to 2010, in 2010, I have roughly, let's say 25. So if I do 25 minus 20, that's going to equal 5. So there's only 5 number increase. So it can't be 2009, 2010. But if I do 2010 and 2011, I'm going to have 20, and then it increases all the way up to 45. And if I do 45 minus 20, that's going to give me 25. Therefore, my answer is going to have to be 2010 to 2011 or D. In which of the following tables is the relationship between the values of x and their corresponding y values nonlinear? So, what exactly does nonlinear mean? That basically means that when y increases, it's not increasing or decreasing. It's not increase or decrease in a constant rate. What I mean by constant rate, like the same amount. So we want to look for the one that changes, like from like, let's say if it's adding 5 and there's adding 6, that would be nonlinear. So let's see which one shows that. If I look at A, I'm going to see that every time the x increases by 1, y equals 8, 11, 14, and 17. In order to figure out there's a rate besides looking at it, let's subtract 17 to 14, and then 11 to 8 and C. If I do 17 minus 14, that equals 3. If I do 11 minus 8, that equals 3. This one's linear, so A is incorrect. If I look at B, I'm going to get 4, 8, 12, and 16. Let's compare that too. If I do 16 minus 12, that's going to give me 4. And if I do 8 minus 4, that's going to give me 4. That's also linear, so B is also incorrect. If I look at C, if I do 23 minus 18, and if I do 13 minus 8, they're both going to give me 5. So C is incorrect, therefore my answer is going to be D, but let's confirm. If I do 48 minus 24, that's going to give me 24. And if I do 12 minus 6, that equals 6. As we can see, they're both different answers. Therefore, my answer is going to be D because it's nonlinear. It's increasing exponentially because it's getting multiplied 2 each time. Because it's 6 times 2 equals 12, times 2 equals 24, and times 2 equals 48. If they were asking for exponential, D would be our answer. Okay, let's do this question. For how many 10 points in the actual y value is greater than the y value predicted of the line best fit? And the scatter plot shows relationship between two variables x and y. A line best fit for the data is shown. So what are they exactly asking for? There's a lot of points. So let's interpret what we're looking for. We're given 10 points, and we're given the actual value that we're looking for the value that is actually greater than the predicted value. What that means is just which values of y is above the line that's given. So we interpret that is see that we have a positive line, and the points that are positive or greater than the y value that's predicted are over here, the ones that I'm circling. And if we count those are 1, 2, 3, 4, 5, and 6. Therefore, my answer is going to be C. And again, it's C because they're greater than the predicted y value. As we can see, let's say let's look at 6. Our predicted value is 6, and as we can see, the point right here, I'm going to do it in green, is above the predicted y value. Therefore, my answer is C, 6, because there's 6 points that's greater than the y value predicted. Okay, let's look at this question. The graph shows the momentum y in Newton seconds of the object x seconds after the object started moving for 0 that is greater or equal to x, and 0 is less or equal to x, and x is less or equal to 8. What is the average rate of change in the Newton seconds per second? That sounds weird. And a momentum of the object from x equals 2 and x equals 6. Okay, so we're given a lot of information. So we're obviously given a graph, x being time and y being momentum, and we're given that it goes from 0 to 8. Those are the points. And we're looking for the average rate of change, and this is important, and I'll go over it in a sec, of the y value momentum of the objects at 2 and 6. Not 2 through 6, 2 and 6. So those two very specific points. And why does that matter? Well, let's interpret it. What does average rate of change mean? So average rate of change is the same thing as slope. Slope is the rate of change. Average rate of change is just slope. They're kind of the same thing. So what that means is that in order to look for the average rate of change, I need to use the slope formula, which is y2 minus y1 over x2 minus x1. Please remember this because it's not given on the SAT reference sheet, and this formula is so important. Well, what does it mean exactly What does it mean exactly? Well, y2 and x2 are just the x value and y value that is greater than the x1 and y1 value. So let's see. If we look at 2 and 6, I can obviously see that 6 is a greater number than 2. So 6 and whatever y value is going to be greater than 2 and whatever y value. And we can figure it out by interpreting the graph. If I look at 6, I can see my y value is 8 for momentum. When it's 2, I'm going to have the y value of 6. Therefore, I have the points 2, 6, and 6, 8. And now I can plug into my formula. y2 is going to be 8, our y1 is going to be 6, our x2 is going to be 6, and our y2, or x1 is going to be 2. So 8 minus 6 equals 2, and 6 minus 2 is going to give me 4. Therefore, my average rate of change is 2 over 4, or 1/2, if we simplify it. Okay, an inspector begins a day of work with a large sample of shirts that need to be checked for deficits. The inspector works at a constant rate throughout the morning. What type of model is best used to the number of shirts remaining to be checked for deficits at a given time throughout the morning? So we're given that the inspector begins a day of work with a large sample of shirts that need to be checked for deficits. And we're looking that inspector works at A, I'm gonna highlight it in a different color, constant rate throughout the morning. And we're looking for which model best represents the shirts remaining to be checked for defects at any given time throughout the morning. So what can I do to figure it out? Well, because it says constant, that basically means, or constant rate, sorry, that means it's slope, remember? We just previously did another question where average rate of change is just slope. Anytime that it says constant rate is also slope as well. I spelled that correctly, I'm very sorry. So constant rate is also slope. And slope is always a straight line, and a straight line is always linear. Therefore, C and D are incorrect because they're exponential, which looks like that, kind of like a J, regardless of where you look at it, like this way or this way. Therefore, A and B are one of my answers. And we're given that which one shows the number of shirts remaining. Remaining basically means that there was a large amount of something, and then there's only a few more to do something. Therefore, there was a decrease. And because there was a decrease, that means that there's decreasing the amount of values of shirts needed to be defects. Therefore, we're going to have a negative slope. So my answer is going to be B, because the amount of shirts in the beginning for checking has decreased because there's only a few shirts remaining. And because it says remaining, we can assume that it's decreasing with the negative slope. Okay, this one might look a little bit tricky, but this one's pretty simple if we understand these concepts. The scatterplot below shows the amount of electricity generated in millions of megawatt hours by nuclear service over a 10-year period. Of the following equations, which best models the data in the scatterplot above? So we're given time in years of energy and million megawatt hours, and this shows the electricity energy generated by nuclear sources. And we're looking for the equation that represents the data above. Well, how can I interpret it right away? Okay, as we can see, A, B, C, and D has a negative or positive 1.674 x squared. How does x squared look like in a graph? It kind of looks like a U. Kind of looks like that, either up or down, right? And it's up when it's negative, or sorry, when it's positive, and it's down when it's negative. So this is positive and negative x squared. So let me write that. Negative x squared. So how can I interpret with the graph if it's positive or negative? Square root, or like the U, sorry. If I connect all the points, so here from 1 all the way to 10, I can kind of see that it's increasing and it's decreasing. And because it's decreasing from 1 to 10, or like it increases and then decreases, it kind of looks like a negative x squared. And if I can draw from 0, which we'll go over it, it also makes it true that this is a parabola that has a negative x squared because it looks like one. Therefore, A and C are incorrect because by interpretation or just observing it, it doesn't look like x squared at all because it's facing down, not up. So A and C are incorrect. If I look at B and D, I have a negative 1.67 x squared, so that is true. So the other thing that's important is looking at the y-intercept. But how can I find the y-intercept? Well, y-intercept, we can look for it when x equals 0. So let's make x equals 0 and find our B and D y-intercept. If I plug in 0 for y, and for B, I'm going to get y equals negative 745.73. And in D, I'm going to get y equals positive 745.73. Let's look at the graph. So we're given positive y values. And if I go from 0, I can roughly say we're probably going to have 45 roughly over here. And that is our graph. This is from 0 to 10. So what can I assume and what can I conclude? Because y is a positive and not a negative, I can say that we're going to have a y-intercept roughly between 740, 760. And because it's positive, our answer is going to be D. Okay, this is another question. For every value that x is greater than 0, the function f is defined as follows. F of x equals 201% of x. Which of the following could describe the function? So we're given that x is any value greater than 0, and we're given that f of x equals 201% of x. So what I can determine, so x can be any number greater than 0. We already know that. And f of x is 201% of x. So we can write 201% as a decimal by dividing it by 100. So if I do 201 divided by 100 to convert to a decimal, I'm going to get 2.1. Therefore, f of x equals 2.01 of x. So now we got to interpret the function given. As I can see, we're given that 2.10, and because it's greater than 1, I can say that it's increasing and not decreasing, because if it was a fraction like 0.99, 0.98, 0.97, ultimately we're going to have a smaller number. Let's say x equals 1, for example. Let's say if I do 0.99 times 2.01, it's going to be smaller than 2.01 because 1 times 2.01 equals 2.01. And because 0.99 is less than 100, it's going to be a smaller number than 2.01. Therefore, when it's less than 1, it's going to be decreasing. When it's greater than 1, it's increasing. And because it's greater than 1, I can eliminate a and b because it's increasing and not decreasing. But how can I figure out if it's linear or if it's exponential? Because we're given a number with x, this is going to be increasing at a constant rate, regardless if it's 1 or 2. Let's see if that's true. If I make x equals 1, 2, or 3, I'm going to get 2.1, or 2.01, sorry, when x equals 1. When x equals 2, I'm going to do 2.01 times 2, which equals 2, or 4.02. And then when it equals 3, I'm going to get 6.03. What do all these have in common? When x, and this is when x equals 1, x equals 2, and x equals 3. If I look at 1 and 2, it's increasing by 2.01. And if I look at 2 or 3, y is increasing by 2.01. So it's increasing, again, at a constant rate. And because it's increasing at a constant rate, my answer is going to be D. What a lot of people get confused in these type of questions, and this is something to point out, is that because it looks like a fraction, because it looks like a percentage and it looks like 200, people think, oh, it's exponential, right? Because 2 point. No. It's increasing at a constant rate, not exponential. It'll be exponential if it was looking something like x to the power of 2. But because it's a number to the power, or a number multiplying x, it's ultimately going to be linear. So the answer is D. Let's look at this question. The scatterplot shows the relationship between the length of y and hours a certain bird spent in flight and the number of days after January 11x. What is the average rate of change in hours per day of the length of the bird spent flight on January 13th to the length of the time bird spent on January 15th? So we're given that x represents the days after January 11th and y is the length of time in hours. And we're looking for, again, the rate of change, so slope. In days per hour of the length the bird spent flying from January 13th to January 15th. How can I interpret it? Well, if we look at the graph, we don't have a straight line. And normally when they're giving average rate of change or slope, we have a straight line. So how the heck am I going to look for my slope? Well, the good thing about average rate of change is that you don't necessarily need a slope. Average rate of change is just the average number between when x increases by 1, regardless of where it is. And whenever it says average rate of change, you just get the information given and you just look for the average. And I'm pointing this out because anytime you're given a question like this, you just you use slope formula to get the average rate of change. Even though we don't have a line or you don't have something that looks like a linear line, that doesn't mean that there isn't an average rate. So anytime it gives the average rate of change, always use slope formula. Always, always, always slope formula. So let's see January 13th to 15th. How can I interpret that? Well, X represents days after January 11. And if I do 13 minus 11, that equals 2. So this is going to be 2 days after the 11th. And then 15 minus 11, it's going to equal 4 days after 11. So let's look at that. When X equals 4, I'm going to get 15. When X equals 2, I'm going to get 6. So I'm going to have the points of 2, 6, and then 4, 15. And now I'm just plug it into my slope formula and figure it out. So 15 minus 9, or 6, sorry, divided by 4 minus 2. 15 minus 6 equals 9. Then 4 minus 2 equals 2. Therefore, I'm going to have the average rate of change for the whole graph of 9 divided by 2. Or if you want to write it as a decimal, it's going to be 4.5. So these two right over here will be my answers. Okay, this is be the final question for today, and we don't need to do any math if we understand what we're interpreting. The scatter plot above shows the federal mandated minimum wage every 10 years between 1940 and 2010. The line of best fit is shown, and its equation is y equals 0.096x minus 0.488. What does line of best fit predict about the increase in the minimum wage over the 70-year period? So we're given a slope, y equals 0.096x minus 0.488. So what can I interpret? Why I say you don't need to do math? Because if we understand slope, which has kind of been this whole point of this video, this question's not going to be that hard at all. So how can I find slope in y equals mx plus b? Anytime that there's a number in front of x in this form, this number right here is always slope. So slope or m, because it's also called m. Therefore, 0.096 is slope. And this increases, this is going to be our value every time x increases by 1. Therefore, when every year after 1940, y or the minimum wage is or was 0.096 on average. And as we can see, that's going to be my answer A. So A is my answer because each year between 1940 and 2010, the average increase in minimum wage was 0.96. Because every time X increases by 1, Y increases by 0.096 always. So my answer is going to be A. This is the last question for today. Thank you for watching.